What's up guys, this is Massey. Welcome to another video. In this video I want to talk about binomial expansion with fraction power or rational power. And this one is also called binomial series because we have infinite number of terms. So let n be the rational number, then for absolute value of x less than 1, the infinite series is gonna be, that's basically the expansion for 1 plus x to the power of n. It's going to be 1 plus n times x plus n times n minus 1 divided by 2 factorial x squared plus n times n minus 1 times n minus 2 divided by 3 factorial times x cubed plus other terms for higher orders. If we change x to negative x, then it's going to be pretty much the same, but it's a little bit some differences. So instead of 1 plus x to the power of n, we're going to have 1 minus x to the power of n. N is a rational number, so it's going to be 1 minus nx plus n times n minus 1 divided by 2 factorial x squared and all the way there. So instead of x, we put negative x here. So that's why nx becomes negative nx. And this one doesn't change because x squared is the same as negative x squared. So the term that has x squared or x to the power of 4 or x to the power of 6 remains the same. But here the next one is going to be negative and so on. If n is the positive integer, it's going to be 1 plus x to the power of n, c0 plus c1x plus c2x squared plus all the way to cn x to the power of n. As you see here, we have finite number of terms for positive integers. If n is negative, for example, if n is negative 1, 1 plus x to the power of negative 1 is going to be 1 minus x plus x squared minus x to the power of 3 plus blah blah blah. Next one, when is 1 minus x to the power of negative 1 is going to be 1 plus x squared plus x to the power of 3 plus all the way there. If n is negative 2, is going to be 1 minus 2x plus 3x squared minus 4x cubed. That's the expansion for 1 plus x to the power of negative 2. For 1 minus x to the power of negative 2 is going to be 1 plus 2x plus 3x squared plus 4x cubed and all the way for other numbers. If the general term, if n is negative k, is going to be 1 plus kx plus k times k plus 1 divided by 2 factorial x squared plus k times k plus 1 plus k plus 2 divided by 3 factorial x cubed and all the way there. If n is negative p over q, it's a rational number. If two numbers are there, we can also write it like this, which is going to be very similar to this one but expanded. Basically, we show the numerator and denominator. Let's see some examples. The first example, it says, what's the approximate value of 1.1 to the power of half, or basically square root of 1.1. So I'm going to say 1 plus x to the power of n is 1 plus nx plus n times n minus 1 over 2 factorial x squared plus n times n minus 1 times n minus 2 divided by 3 factorial x cubed and rest. So instead of 1.1, I can write 1 plus 0.1 to the power of 1 over 2. That's going to be 1 plus n is 1 over 2 x plus 1 over 2 minus 1 divided by 2 factorial x squared, which is going to be 0.1. I can write it here. Let's substitute it now. 0.1 to the power of 2. And next one is going to be 1 over 2 minus 1 over 2 minus 2 divided by 3 factorial 0.1 to the power of 3 and all other terms. So now we need to calculate it here. That's going to be 1 plus half of 0.1 is going to be 0.05 plus 1 over 2, negative 1 over 2 divided by 2. 0.1 to the power of 2 is going to be 0.01 plus 1 over 2, negative 1 over 2, negative 1, 1 over 1 and 1 over 2, 3 factorial, which is going to be 6. 0.1 to the power of 3 is going to be 0.001 plus all other terms. So let's approximate it for the first 4 terms then. So that's going to be equal to 1 plus 0.05, and here we have negative 0.00125 plus that's going to be 6.25 times 10 to the power of negative 5 plus all other terms. So that's going to be approximate to 1.04888125. That's going to be the approximate value of 1.1 to the power of half. If we find out the analytical value, if we put in the calculator the square root of 1.1, that's going to be 1.0488088848. So basically the first 1, 2, 3, 4, 5 digits are the same all the way up to here. Let's look at the next number. Next example. It says what's the approximate value of 1.02 to the power of 1 over 4. So that's gonna be again 1.02 to the power of 1 over 4 is the same as 1 plus 0.02 to the power of 1 over 4. That will be 1 plus 1 over 4 times 0.02 plus 1 over 4 times 1 over 4 minus 1 divided by 2 factorial 0.02 to the power of 2 plus 1 over 4 minus 1 1 over 4 minus 2 divided by 3 factorial 0.02 to the power of 3 plus all other terms. So now we need to calculate them. It's going to be 1 plus, that will be 0.005 plus negative 3.75 times 10 to the power of negative 5 plus next one is gonna be (4.375 times 10 to the power of negative 7). So when you add them, 1 plus 0.005 is 3.75 times 10 to the power of negative 5 plus 4.375 times 10 to the power of negative 7. That's gonna be 1.004962938. So 1.02 to the power of 125 is gonna be, if I've punched in the calculator to find out the value of 1.02 to the power of 1 over 4, the answer is gonna be 1.0049623938. So it means that all the digits are the same except the last one. So the approximation is really good for this example. It's very close to the real number, exact solution. Let's look at the next example. This example, it says if 1 plus ax to the power of n equals to 1 plus 8x plus 24x squared plus the rest of the terms, then find the value of a and n. So I'm going to say 1 plus ax to the power of n will be 1 plus n times ax plus n times n minus 1 divided by 2 factorial times ax to the power of 2 plus all other numbers. So these are given. It means that an is 8, n times n minus 1 divided by 2, a squared is 24. So if you divide them, so what we can do, you can say, for example, a times n is 8, so a is 8 over n. We sub it in the second one. We're going to say n times n minus 1 over 2. 8 over n to the power of 2 equals to 24. So then it's going to be, these cancel out, it's going to be n minus 1 over 2n equals to 24 over 64. Then you cross multiply. Or you can simplify it first. Divided by 8 is going to be 3. Divided by 8 is going to be 8. So when you cross multiply, it's going to be 6n equals to 8n minus 8. So it means that 2n equals to 8. So n is 4. A will be 2. Now next example. Write the first three terms in the expansion of 1 minus 2x to the power of negative half in ascending power of x, where the absolute function is less than half. So 1 minus 2x to the power of negative 1 over 2. We need to write the first three terms. So based on the formula, I'm going to say that's going to be 1. So we already know that the formula was, I'm gonna show it here. 1 minus x to the power of negative k equals to 1 plus kx times k times k plus 1 divided by 2 factorial x squared plus all other terms. So based on that, I'm gonna say 1 plus k is 1 over 2 x plus 1 over 2 plus 1 over 2 factorial. Instead of x, you need to write actually 2x, because the term here is 2x. 2x to the power of 2. That's basically is going to be the first three terms. So 1 over 2 times 2x is going to be x. And here, 1 over 2, 3 over 2 over 2, 4x squared. So that's going to be, these 4 and these cancel out. It's going to be 1 plus x plus 3 over 2x squared. That's going to be the first three terms of this expansion. Let's look at the next example. It says, use the binomial theorem to expand 2 minus 3x to the power of negative 2 in ascending powers of x up to and including the term x to the power of 3. So 2 minus 3x to the power of negative 2. I need to take 2 out. 2 to the power of negative 2. 1 minus 3 over 2x to the power of negative 2. So when you write it like that, 1 plus negative 2 times negative 3 over 2x plus, actually k is negative 2, but I need to write the positive because these two cancel out. Negative and negative is going to be positive. Then it will be, next term is going to be 2 times 2 plus 1, which is 3, divided by 2 factorial. 3 over 2x to the power of 2 plus 2, 3, 4 divided by 3 factorial. 3 over 2x to the power of 3. Then when you simplify it, 2 and 2 cancel out. It's going to be 1 plus 3x plus 3 times 3 over 2 to the power of 2x squared plus, this cancel out, 4 divided by 4. 4 times 3 to the power of 3, 2 to the power of 3, x to the power of 3. When you simplify it, it's going to be 1 plus 3x plus 27 over 4 x squared plus 27, 108 over 8 x cubed. And don't forget that we have 2 to the power of negative 2 behind the final answer. So we need to say 2 to the power of negative 2 multiplied by these terms. And same thing here. So that's going to change it to 2 to the power of negative 2 is 1 over 4. So it's going to be 1 over 4 plus 3 over 4x plus 27 over 16x squared. And here we have 108 divided by 8, 54, 27 over 2, 27 over 8x cubed. Plus all other terms, but we needed to stay here because it says including the term x cubed. Now let's look at the next example. Next example, it says show that the binomial expansion of 4 plus 5x to the power of 1 over 2 in ascending powers of x up to and including the term x squared is 2 plus 5 over 4x plus kx squared. You need to find out the value of k. So 4 plus 5x to the power of half. I take 4 to the power of half out. So this one is going to be 2. Which is going to be, when you expand this one, it's going to be 1 plus 1 over 2, 5x over 4, plus 1 over 2, 1 over 2 minus 1, divided by 2 factorial, 5x 4. We don't need to write the rest because it says up to x squared. So when you multiply, it's going to be 2 plus 2 times half cancel out, 5x over 4 plus half times negative half. These 2 and 2 cancel out. It's going to be negative 1 over 4. It's going to be negative 1 over 4. This one is 25 over 16 x squared, which will be 2 plus 5 over 4x minus 25 over 64x squared. So the number of k is negative 25 over 64. That's the answer to this question. Next example, it says find the binomial series expansion of square root of 4 minus 9x when absolute function of x is less than 4 over 9 in ascending power of x up to and including the terms x squared. So square root of 4 minus 9x is going to be 4 minus 9x to the power of 1/2. You take 4 out. That's going to be 2. So it's going to be 2 times 1 plus 1 over 2 negative 9x over 4 plus 1 over 2 minus 1 over 2 factorial negative 9x over 4 to the power of 2. When you multiply it, it's gonna be 2 minus 2 and 2 cancel out, 9x over 4 plus 2 and 2 cancel out, 1 over 2 times negative 1 over 2 is going to be negative 1 over 4. So it's going to be negative 1 over 4 times 81 over 16x squared, which will be 2 minus 9 over 4x minus 81 over 64x squared plus all other terms. And now let's look at the last example of this video. Find the first 4 terms of the binomial expansion of cube root of 1 minus 2x. So that's going to be 1 minus 2x to the power of 1 over 3. That's going to be 1 plus 1 over 3 times negative 2x plus 1 over 3 minus 1 over 2 factorial minus 2x to the power of 2 plus 1 over 3 minus 1 over 3 minus 2 over 3 factorial times negative 2x to the power of 3. That's going to be equal to 1 minus 2 over 3x. 1 over 3 minus 1 is negative 2 over 3. 2 and 2 cancel out. It's going to be negative times negative 1 over 9 times 4x squared. And the next one is going to be 1 over 3 times negative 2 over 3 times negative 5 over 3 over 6. And here you have negative 8x to the power of 3. Now let's simplify. The 1 minus 2 over 3x minus 4 over 9x squared. Here you have negative becomes positive. You have negative. So that's 10 over 27. 10 over 27. So 4t over 81, because 27 times 3, this 2 and 2 cancel out. It's going to be 4. 4 times 10, 40. And here we have 81x cubed. So that's going to be the 4 terms of this binomial expansion, which is cube root of 1 minus 2x. I hope you enjoyed this video. Please leave me a comment if you have any question. Thank you for watching and have a great day.